Hey everybody, good morning, good afternoon, or good evening, wherever you're coming from. Welcome to GameDay Essentials. I'm Scott Ward, Solution Architect here at AWS, and we are coming to you from a very secret location somewhere within the AWS ecosystem. I'm glad to have you back for another GameDay Essentials episode. I guess the last one went so well that they've picked up our contract for a few more episodes, so we have a lot more to share with you guys and to spend some time with our GameDay audience. Normally, David Potes would be with me today, but David is out on special assignment for us. So in his place, we have another colleague of mine, Joe Fontes. Joe, would you like to introduce yourself?
Thank you. Yes, I was the second choice behind Dave, as well as three other staff, but I am happy to be here today. My name is Joe Fontes. I am a solutions architect with AWS, and also I play a few parts in GameDay, part of that team that kind of helped put it together with Scott and some others. So really excited to be here today, and I'm going to pretend that I was first choice.
Perfect. Well, thanks everybody for coming in and talking to us today. We're going to take a few minutes and just kind of reset the stage for anybody who wasn't present in our episode last week or maybe came in a little bit late. Well, let's start with talking about what GameDay is really quick, much faster than we did last week. So GameDay is an AWS event that we put on around the country and around the world really, where you are put in the position of being an employee at Unicorn.Rentals, which is an amazing startup company. They're very popular in the kind of renting out these magical unicorns for you to take home to your kids and consume. It's your first day on the job at this new company. You've had a chance to meet with leadership. One of the first things that you've learned is that the team that built the application that you're supporting has all left the company. So you are now part of a brand new team of people that you've never met before, tasked with having to support and run an existing application. Now, that application, you don't have a lot of details about it. You have been left behind this amazing run book, which the team created, and it's got lots of typing as well as lots of notes in it that kind of give you some insight into the architecture and the application you're supporting, but maybe not all the details. You're going to have to figure out fact from fiction from that. And I think we've all seen a few run books in our day that are a little bit questionable. Would you say, Joe?
Yeah, I'd say this is about as accurate as anything I've ever seen walking into an organization. So I feel pretty good about it.
Okay, very cool. So you're sitting on this team. You've been given a brand new application to support. You have this questionable run book, and you now have an AWS account that is supporting and running the application that you're there to support. So at the end of the day, what GameDay is really about is that you figuring out how to work as a team, how to understand the architecture of the application that you're running inside an AWS account, and how you're going to evolve that architecture to be able to react to events that are happening throughout the day. Those events could be external to your application, internal to your application. They could be technical, they could be social. There's lots of different things that come up with this, and we're really kind of putting you in kind of maybe a somewhat real-world situation. I'm sure all of us have had some sort of an experience at some point or another where if, at the minimum, you're coming in and supporting something that you didn't build, and you've got to figure out how to deal with it, and you probably don't have as much ramp-up time as you'd like to have. So that's what GameDay is, and that's what we're here to kind of preach to you guys and help you get more understanding of what it's like in GameDay and some of the concepts that you really want to do and see. And we're going to take some time and dive into the management console and talk about more of those today. So stay with us, and we'll talk about some of that.
Well, you forgot one of the most important components.
What's that, Joe?
You know, the dynamic, engaged, interactive CEO, which all of these individuals are working for. And what's that? Why, yes, I do play the CEO. Yes, I do play that character at GameDay. So yes. For anybody that's attending a GameDay event, just remember to laugh at the jokes that you might not realize are funny, but are actually funny.
Yes. We've practiced them on many people, and they've been proven to be funny in most cases. So
we need a laugh track.
Yes,
that's what we need. Yes. So for the next version of GameDay, we will get a laugh track, just so you're aware of when these things are actually funny.
So on that note, we actually want to kind of give everybody a kind of an overview. We actually ran a GameDay event at the Chicago Summit last week. So first of all, if you were at the Chicago Summit last week and you're on the stream, feel free to chime in on the chat. We'd love to hear from you guys if you were an attendee. But Joe was at the summit last week, and I want to give him just a couple minutes to kind of give an overview of how that event went, and he's even got a few pictures of the event to share with us. So Joe, can you kind of tell us about last week and how that went?
Sure. Whenever we run a GameDay event, predominantly Scott is involved with a lot of the planning, working with local resources, engaging, our staff, our support staff, and additional players. But I don't know if you recall, we actually abandoned us for the Chicago game day. So we were left to our own devices.
I was working on personal development.
Yeah, well, we still made it happen. It still worked out. And so, I'd like to thank everybody that attended, was able to participate. Here we have I'm not sure, can everybody see the screen? We have some pictures of the Chicago Game Day event that we'll kind of go through real quick, and just kind of highlight, some of the a little bit of the fun we had. Here you'll see a picture of the Chicago skyline. What's that? No, this is not a professional photo. This was actually taken on my camera, on my cell phone. So I know what you're thinking, like, wow, is this like a Pulitzer Prize piece? But actually it is.
Looks like it was shot on an iPhone.
Yeah. No, hey. No, this is. It looks better. And so here's a glimpse of a little bit of what the Chicago Summit looked like for Game Day. We have the competitors that are, as you can tell, they have a pretty intense focus. We had 27 tables of 4 teams apiece, and it's really interesting. It's so exciting when you first walk into an event like this. If there's a little bit of excitement in the air. Nobody knows what they're gonna participate in, but they know that they're in a competition with the table next to them, and they have to work in a team. And one of the things I really like is that it doesn't matter what your skill level is with something like Game Day. We make sure to place individuals that don't have as much experience with those that do, to ensure that everybody has a great, a fun, engaging, and educational experience with something like Game Day.
Cool.
This is my attempt at a panorama. As you can tell, I think somebody was walking across the middle of it. We're going to ignore that and just say this is another fantastic photo. And then yes, so as you can tell, I am not a professional photographer, but you could mistake my work for one.
Right.
And then here was the winning team at the summit. So for those that were thinking about attending a game day or are planning on it, if you win, if you are the top scoring team, you get your name on this trophy right there.
Yeah.
And that's something that could just end up in the halls of history right there.
And that trophy, we use high quality masking tape to write the team names on that trophy.
Nothing but the best.
And it goes around all over the place. That trophy is unfortunately still in transit, so we don't have it here live. But we will get it to one of our future episodes here in the near future.
And I'm sure there's a lot of people that wanted to see the unicorn trophy.
Yes.
I mean, it's surely something to behold, Scott.
Yeah. So Joe, did you find that the Chicago event did you qualify as a success overall?
Oh, absolutely. Okay. So, it's always different. You talked in the last segment a little bit about reInvent, what game day looks like at reInvent. And it's really interesting kind of the different styles of competition between a large scale event like reInvent, kind of a medium scale event like the individual Summit series, and then something a little bit smaller. So like the next picture we have here is one of the smaller game day style events that we run that you've done, I know, just a ton of. This one was an internal event, so it's a little bit smaller, but really it's engaging in the way that you interact with all of these different teams. With something like as large as reInvent, there are so many teams and there are so many possible solutions and there's so much innovation in a single room that you just get sucked into, wow, what are they doing? What are this team doing? What is this team doing?
Right.
And something like the Summit series, we're able to have smaller groups of teams and so have more one-on-one engagements with the teams. We're able to spend a lot more time with them.
Cool.
And so it's really interesting in that you get to see how is it that they work through the problem.
That's great. Very cool.
Oh, and look at this. Oh, yeah, there is Scott post another game day event.
We all need a little downtime.
There we go.
Well, very cool, Joe. Thanks for giving us that overview. Now, obviously, you've mentioned reInvent, and I think you have one more picture to share with us. The Chicago event seemed pretty big, didn't it? Do we have another?
Oh, yes.
What's the size of a reInvent game day like? So that's a much bigger forum. So clearly, reInvent is kind of a very large event for us. So it's the same thing, but just at a much larger scale. So if you guys happen to be at reInvent this year, Game Day is up and listed. So if you guys can make it out to Game Day at reInvent, well, we'd love to see you. It will definitely be different than other game days that we've done in the past. We'd love to see you guys out there.
So Scott, are we willing to give any details on what the future holds for Game Day at reInvent? Or should we save that for later?
I think we're going to save that for another day, guys. We want to bring you in. We want you guys to have as much fun as possible. So
somebody's got to watch this till the end.
So let's take a few minutes and just kind of cover what we did in the last episode, episode 1. Last week was focused on, once again, educating you guys about GameDay, but we also focused on recon. So, as part of that game, you've been given a brand new AWS account. You have no idea what's in it. You didn't create it. You didn't build anything in it. So we talked about some different strategies of how you might do reconnaissance and figure out what's in an account. You might use CloudTrail to look at events that have happened to figure that out. You might look at some other logging of seeing what's in there. You might actually just start going into the management console and clicking on every service to see what's there, which will wear out your thumb, your finger, whatever you're using to click, because there's lots of 70 plus services and 14 plus different regions to investigate. But you can do that. We recommend maybe you start with the foundational services, around compute and database and storage and network, to kind of maybe work from the base up to figure out what's in your account. We also talked about some automated approaches of writing some scripts. I talked about a few simple examples of the command line interface, where you might be able to run some scripts.
Did we agree that PHP was the ideal language for writing these scripts?
There was a furious debate about PHP as far as being the ideal language for that, and we had some very harsh critics of PHP and some very proponents of PHP, so it's still undecided.
Oh, I didn't know if we did any polling.
We didn't do any polling, but we did decide that it's most appropriate to pick the language that you're most comfortable with, I think, at the end of the day.
I think we can all agree to that.
So we definitely talked about an automated approach to kind of build a script to figure out what's in your account, and the cool thing with that is the portability. You can take it with you, hand it off to teammates, or bring it with you to your next account that you're auditing and stuff like that. So there's definitely some reusability aspects to that. So, we talked about the recon stuff, and I'm kind of curious: is there anybody else in the audience today? Did you have any other thoughts on how you would do recon in an AWS account, or things that we talked about that you went back and thought about last week that you think would be good ways for you to figure out what's going on in your particular AWS account? If you have some thoughts or some things you learned or other ideas, throw them into the chat window for us.
Yeah, it's really interesting when you see a platform with as open APIs and accessibilities. With the number of languages where we've developed an SDK for it. Just the ecosystem of tools and scripts and open source projects that are dedicated to really kind of visualize it. The partner products. It's really interesting. I'm constantly kind of surprised when you come across a new partner product and you see that it does a diagram of your entire infrastructure, and you look at it and say, wow, I actually forgot about that piece.
Yeah. There's definitely an oh wow factor that comes with some of that stuff. I would agree. All right, so we're going to take, just to kind of recap, some people have come in a little bit late. You are listening and tuning into and watching GameDay Essentials today, and we are taking you through kind of a multi-episode journey of learning what AWS GameDay is and helping you understand some of the core concepts and things that you might want to know and help you get familiar and be successful when you get to participate in a future GameDay event, either for the first time or again. We do not prevent people from doing GameDay more than once, so you're welcome to do it again as well. So we talked about recon last week, and so with that, what we've done is we've actually got an AWS account, and we did some reconnaissance of on our own to kind of figure out what's this initial architecture that the fine people at Unicorn Rentals have given us to work with. And we actually created a little diagram of what that architecture looks like, and Joe's got a screenshot of that architecture that we can show here. And we'll make it a little bit smaller because there's so much stuff on this slide for this massive architecture that we're dealing with. But this is our architecture. This is what we figured out is sitting in our account right now. We have a Route 53 hosted zone that is sending traffic to an EC2 instance that's sitting inside an availability zone, inside a virtual private cloud, inside a particular AWS region. So that's our starting architecture. That's what the people at Unicorn Rentals have given us to work with as game players. So I think we might have some room for improvement in this overall architecture.
I mean, but how many times have you seen something like this where it's your first time deploying anything in AWS?
Yep.
It's there's a saying that we have: treat instances like cattle and not pets.
Right.
And you go in and you see it's a single website running on a single instance, and your heart just kind of stops and you think, wow. We've really got to fix this.
Yeah. I would look at this and I would go, I would classify this as test or proof of concept.
Yeah.
I wouldn't call this a production ready
we'll call
architecture.
It at risk.
At risk. This is not well architected. If any of you looked at our well architected program. So today we're focusing talking about scaling. That's our episode. That's the core focus of our episode. And so, scaling is really important, and it's an interesting value prop on AWS. You get the ability to scale when you want, as you want, with lots of different AWS services that we offer, not just EC2. And it's really different than you might find in an on-premise data center. So Joe, if you were running in an on-premise data center and you had to scale an architecture, what would you do to scale it? Would you add stuff as you needed, or if you were actually in a data center, what would you do for scaling?
That's an interesting question because first I would ask. It's rhetorical, but I would ask, what year are we actually in? Mm-hmm. So if we're talking about prior to mainstream deployment of hypervisors, we're talking about back when everything was bare metal, and maybe you had like some VMware, another virtualization here and there, but predominantly you had bare metal instances. Mm-hmm. Ensuring scaling capacity meant having actual physical machines put in your data center racks. Mm-hmm. And I think at some point, I guess I'm now older folk, but as the older folk have kind of experienced that, where you just have, if you're cost conscious, you had like a wall of those white boxes,
right.
And it was the same amount of capacity whether or not you had users or not. It was 24/7.
You're provisioning for peak.
Yeah, absolutely.
Yeah.
And it's peak plus, you imagine 10% are going to fail.
Right.
That was back when the little capacitors used to pop when it got too warm.
Yep.
And then, kind of moving forward, things became a little bit more variable. The use of hypervisors within data centers give you a little bit of leeway, but you still had to kind of plan for the worst case scenario.
Right.
It's, what if users hit every site at once, plus we lost 10% of our machines due to some kind of issue, whether it's networking or anything, and so it's kind of what we historically have been used to dealing with. Mm-hmm. And so when you think about what are the scaling decisions you make in a data center, mm-hmm. a lot of it really can involve a little bit of that classic thinking, mm-hmm. until you really get used to how does something like auto scaling work and take place.
Right. Awesome. So we're talking about scaling, and we've given you this amazing architecture, and we need to figure out how we want to scale this architecture out. And so I'm going to actually ask the audience, there's lots of different things that we could do when it comes to scaling and things that we could start working on for this architecture. And we'd like your feedback. What do you guys think are the first things we should tackle with this? We're actually going to jump into the management console and walk through actually re-architecting this application and talk through what we're using as far as those services. So give us some feedback. What would you guys do to start with this for this particular architecture? We'll give you guys a few seconds. Give us some ideas, and we'll jump into those and start talking through them. So we've got our first feedback is a little bit of a multiple availability zones. Totally agree there. If you have a disruption in one availability zone and that EC2 instance is in it, your application is down. So being able to run across multiple availability zones is certainly an aspect we want to see in that architecture, and we'll find a way to do that. What does everybody else think, besides Storm of Dads?
Feel free to get kind of creative. Maybe we have solutions that, I certainly have solutions that I tie to my personal preferences. These are the tools that I've been using, mm-hmm. and this is the way that I've been using to move forward. But there's a lot of really, really innovative things that people are doing. There's tons of, I just saw a really cool deployment with Kubernetes or with Mesosphere. So it gets really creative.
Cool.
So
let's head into the management console, Joe, and let's get started. So we've got an idea of multiple availability zones. So we have another one. Storm of Dads has talked about an ELB floating in a couple of availability zones, feeding a bunch of EC2 instances and multiple AZs. Somebody else has called out a minimum of 3 of everything and used geoload balancing. We've got more about the ELB and auto scaling groups. This is good, guys. Running servers is so passé. Can't we go serverless? That's a nice one. We've got CloudFront, another idea about CloudFront. We have some awesome ideas, and I think for this particular architecture and for this, the GameDay approach, let's talk through some of those things. And I think they all tie together, but I think maybe a good starting point for this that was called out is maybe auto scaling.
Yeah,
and we talk through let's actually go out and build some auto scaling around this architecture while we right here. And so we'll start that off, and then we'll talk through some other things, and I'll interact with our group here while you're doing that, Joe.
Wow, looks like we don't have an auto scaling group.
Well, that sounds like we need to start off with creating one then.
So here we have, so in order to create, so when you look at what is an auto-scaling group, it takes instructions from a launch configuration and decides how many, based upon the rules that we decide, and we're going to go through some of those examples. Based upon those rules, it decides how many instances should be running if behind the specific load balancer, should we attach a load balancer. So, really we'll start off with this launch configuration to help instruct, what it is that we're going to actually be scaling.
Right.
So do we just want to use the standard?
Yeah, we just use a standard. Let's start off with, we're showing everybody what's going on.
All right, we'll use a nano and being frugal. So this is going to be, so we're going to name it, so we're creating our launch configuration. This is where you want to have a little bit of versioning in mind with how it is that you want to name a launch configuration. You'll find that instead of going through making changes to a launch configuration, you're going to be creating new ones, maybe using the last one as a reference, but still you're always going to be creating new launch configurations. So here we'll have, use a Unix timestamp. We'll just use it, we'll say LC.
A lot like launching a normal EC2 instance to start with.
Yes, it does. Yes, it does. So we'll probably have a security group identified already, which is, we'll use the instance security group. Here you could create a new security group along with that. So we'll review our settings here, and so with the last steps, what we've done is decided this is the operating system image, the AWS AMI, the machine image. So this is the operating system that we want to install. If we had custom software, this is where we would have identified that specific image associated with that custom software. What type of instance we're going to be running. So here we have the T2 Nano to be frugal. And then some additional details. This is where we could also add things like, do we want to have something execute upon start of the scripts, things like user data.
Right, right.
And for now, we'll just keep it as standard.
Okay.
Oh, whoops. We have.
There may not be a key in this account,
we'll
by the way,
just,
so
that's fine.
Launch it. So the point here is that this is all we do, or is this the first step?
Yeah, this is really step number one.
Okay.
So before we get to how many instances should there be running at the start of scaling, how should it scale up, how should it scale down, how does it meet capacity needs? Before we do that, we have to figure out what is it that we actually want to run, right? So if you have your web application that you're trying to scale, let's say it is unicorn.rentals, how do you know which software should be tied with that auto scaling group? And this is what we do. This is where we define that within that launch configuration.
Perfect, perfect.
And now that we have that launch configuration,
so what are our next steps?
we're gonna attach it to an auto scaling group.
Okay.
Look at this. And it's right here. Wow, this is some ergonomic design. Is that a button right there to create an auto scaling group based off of this launch configuration?
That's perfect.
So here we're going to have our, we'll name it unicorn rentals. Let's just do unicorn auto scaling group. So what we're going to do is start off with one instance. This just ensures that one instance will always be associated with this auto scaling group. One of the base scaling models that you find is if you want to have, as it was mentioned, let's say 3 instances running. If you put a 3 in here, they'll always keep 3 instances running, so that even if you don't define additional rules based on scaling, you'll always know that AWS will try to keep 3 instances running no matter what happens on the instance.
So that's your steady. That's almost considered your steady state.
Yeah, it's your baseline.
That's like, at a minimum, that's what we need to have running at all time.
Yeah,
okay, cool.
Absolutely. So we're going to keep it as.
So now subnet. Let me stop you there on subnet for a minute, because one of the callouts here was a multiple availability zone type approach.
Yep.
If I remember correctly from autoscaling, this is where we would actually implement that multiple availability zone approach for our application to run across multiple availability zones. Do you agree?
Yeah, absolutely, absolutely. So if you only selected one subnet, then that one subnet would be associated with one availability zone, and so should there be an issue with that availability zone, your application would no longer be available.
Right. So by choosing, can we choose multiple subnets in this? Is that
Why, yes, we can.
Okay. So by choosing multiple subnets, we actually get the ability, autoscaling will actually spread as it launches instances. It will actually bring them up in each of the availability zones, and it'll even be smarter and know if there's a disruption in availability zone, it'll relaunch instances in the healthy availability zone to help you maintain that level of instances that you want. So the people that called out running multiple availability zones, this is where we actually implement it. First of all, you obviously have to define that in your virtual private cloud and in the network, but this is where we actually configure that for scaling to actually be used. You saw Joe pick 2. We could actually pick all 3 availability zones if we wanted to, but we're at least picking 2 right now to help this go forward. But we can easily pick 3 as well. Okay, cool.
And so, as we mentioned, what are some of the decisions that we want to make? We'll kind of get into that in a little bit. So I think right now, probably the best thing to do would be keep it at its initial size. What do you think?
Of 1, right?
Yeah.
So I think that's a good starting point.
Right now, I mean, definitely there should always be 1, except when there's not. We'll do notifications later, so. Oh, jeez. Oops. So I chose the wrong VPC.
Okay.
We're going to pretend that didn't happen.
Okay. And this VPC only has 2 subnets and availability zones available to us, so that's all we'll choose for that one. Yeah, that's a good point. Lost cause that you can, we're starting with 1 instance, but you can scale to hundreds of thousands of instances over a long period of time or over a short period of time, or you could scale just 1 or 2 instances at a time. Auto-scaling is going to be different for everybody. If you read the blog post about AWS Prime Day last year, we scaled to hundreds of thousands of instances over a 30-day or 30-hour period. There was a metric that it was more than Amazon as a company had run on a couple years ago. So scaling has different patterns for different companies, and so it helps different people in different ways, but it can be a very small or it can be a very large scaling event that you might be implementing.
Yeah, and what's interesting too, we always associate scaling with just standard EC2 instances, but the stories that we've heard about spot instance scaling as well with healthcare related workloads, genomic workloads, it's kind of mind-boggling at times.
Right.
The compute capacity that's just available on demand.
Yeah, that's very, very cool. So what do we have now, Joe? So you look like you're at a completed screen. So what do we have now? Do we have everything in place?
So we have. So right now we have an auto scaling group that will make sure that 1 instance is always running. But we do not have this linked to any specific load balancer.
Right.
So right now, and that's not a necessity. We can create auto scaling groups that are not using an AWS ELB or application load balancer. It is optional to attach those. Right. So I think the question is, as far as personal preference goes, are you feeling ELB? Are you feeling ALB?
Definitely. I mean, the group here is called out that they want to see that they should see an application, an ELB, whatever flavor it might be, that sits in front of these. Because and it does make sense to me because this is a web application that we're serving up. So more than likely, there's a need to balance load. But as you're creating that load balancer, I will say, the auto scaling, you could certainly have an auto scaling group that is not tied to a load balancer. There's great examples of having auto scaling based on reading out of a queue, where you're flexing up and down your instances based on a metric in a queue. So there doesn't have to be a load balancer in front of an auto scaling group for you to take advantage of auto scaling. But for this exercise, we are going to go through and implement a load balancer as well.
All right. So you feel like going classic, or you feel like all right, we'll
go classic. Classic's a little faster.
Golden oldies.
ALB is the popular choice right now, but we want to give enough time to walk through everything here.
All right. Oops. So just as we identified what subnets are going to be associated with the auto-scaling group, we're also going to want to associate those subnets with our load balancer as well.
Okay.
As well as the application ports. So typically in a web application, you're going to see HTTP, TCP port 80 as well as port 443.
Right.
As a kind of a side note for those that have had experience with AWS Certificate Manager, I would give it a try. It's a really interesting, relatively new service offering that gives you free to use SSL certificates at encrypted endpoints for your personal website for any domain that you host.
Okay.
So it's
Very
kind
cool.
of part of that effort to encryption everywhere.
Great. Okay. Good point.
And then once again, we're faced with the question of what are we feeling for a security group. This particular security group was already created, and this allows port 80 HTTP traffic.
One of the interesting things, while Joe's dove into that, I'll talk to you about security groups, is that you can actually have, if you're implementing an ELB and an autoscaling group, you can actually have the ELB can have a security group that's maybe open to the world to allow all traffic over port 80 or over 443. Your EC2 instance can actually have a different security group that only allows traffic from the ELB. So it kind of helps funnel that traffic and ensure that people aren't able to bypass your load balancer to get to your application servers. It's kind of kind of limiting that scope around how you interact with your EC2 instances. So it's definitely an approach you can take as far as constructing your security and implementing it for your application tiers.
Yeah, that's a good call. One of the areas when deploying a new load balancer that I like to take into account is take a look at this screen. By default, your healthy threshold takes 10 positive passes in order to be implemented. If you're looking at an interval of 30 seconds, that means you need 10 successful 30-second waits before an instance will be healthy.
Right.
So I usually dial these numbers down a little bit, especially for something like GameDay, where this is really competition-based. You want to do things as quick as possible. For GameDay as well as life, if you want to take a look at this segment. So we're going to bring it down to 2, and then.
And while Joe's doing that, I will tell you, having supported a lot of game days, I have had more than my share of you're at a support table, you're talking to them, and they're saying, why are these instances not coming in service in this load balancer? And it's like immediately it's a hint of like, okay, let's go look at what those health checks are, and explaining to them that it's all working, but it's going to take 5 minutes before your instances actually pass all their health checks, and helping them understand that and to construct maybe a more metric that makes more sense for them as far as what that application is. But those are the defaults, and we see people get I'd say bit by that, but they overcome it. But that's a very common thing that we see in GameDay.
We killed off all of them?
Where's your load balancer?
No, I don't know. Wait,
Very good. Okay.
So many times that happens.
We have a couple of instances showing up here. Okay. Cool. So, and one of those is tied to our autoscaling group. Is that correct, Joe?
Yes. And that would be the first one here. The first one here is our original image instance that was launched.
Okay.
And then the one above that has been created with the autoscaling group. So that is at a count of 1.
Okay.
What you're going to see now is, where's the load balancer? So with our load balancer, we're looking at what instances are associated. And as we mentioned, they still have to go through those 2 health checks. So it should be relatively soon that at least one of these instances kind of joins the load balancer.
Okay.
But, oh no, turns out the other instance isn't running the actual software, so it's not going to be able to join.
So we're expecting that it's going to be out of service.
It'll stay out of service. Okay. But the interesting thing is that when we work with the autoscaling group, we've only said keep 1 is our max and min number. If we said make that 5, the load balancer will keep marking them as not healthy and start cycling through instances.
Okay. Cool.
So it's really interesting when you see in your EC2 console a bunch of terminated instances that you didn't terminate.
Right.
That's always something to look for. Is there something wrong with that image that's launching?
Got it. So you bring up a good point here that I had in my notes here. That one of the things that we talked about is you mentioned that it's not running the software. That the autoscaling group or the instance created by the autoscaling group is not running the software. Based on a little bit of knowledge around how GameDay works, what could we show them that kind of shows, hey, here's how you actually would configure that autoscaling group to run the software? I think the term user data is something that we probably want to talk about here. how would we implement something like that?
So here, once again, the way that the instances are configured is based upon the launch configuration.
Right.
So here, this is one of those examples where we have to update that launch configuration, associate the security group with that new launch configuration, and then start removing instances from that old configuration.
Okay.
And it's really cool how dynamic that happens. Once you have these, this is a process that happens pretty often in production,
right,
where you have new software that's associated with an image.
Right.
And so you need a way to kind of go with that blue-green deployment. And so you could just start removing and terminating those old instances, and auto-scaling will start back populating them.
Awesome. Do we have the user data available to us, where maybe we could copy a launch config and throw that into there?
Just for reason, I was just going to do like yum update, yum install Apache, HTTPD, etc.
That's fine. Yeah, I think the launch config might even be on the original instance as well, or the user data.
Oh yeah. All right, good call. All right, we can do that.
Okay. Kind of quick reset for some of the people who may have joined us late here. Once again, this is GameDay Essentials. We're on episode 2. We're focused on scaling today. We're talking through some approaches that you might take to increase scaling and at the same time high availability for this suboptimal architecture that we've been handed by the Unicorn Rentals company as part of our first day on the job. So we're walking through a few different strategies here. We're talking primarily around auto-scaling on the Elastic Load Balancer at the moment. And more specifically, we're focusing on what we might do for user data. If it doesn't work, Joe, we can throw it in here. We can just throw it in here. But we're talking through the concept of how you would basically bootstrap an EC2 instance so that it, as it auto scales, it can actually do the things that you want to do. So no big deal if we don't have the actual.
We'll just do we'll do like the blank Apache
put
default
something in there real quick there, just to kind of show people how you would add it in. So at this point, we've got an auto scaling group that we've created. It's running across multiple availability zones, as our many of our listeners have suggested that we want to do, and that helps us to ensure that we have high availability across multiple locations, and that if there's a disruption with one availability zone, our application will continue to run. We are put an Elastic Load Balancer in front of that so that no one instance becomes overburdened, and as auto scaling removes or adds instances, the load balancer will know about that and continue to spread traffic among all of those instances. And in a moment here, we will have some user data added to our launch config as well to show you that example. So I'll ask the group here again. So Joe's going through and adding kind of some basic examples of launch config or of user data. So you can see here that you can put in a simple or very complex shell script. I love working at the command line, by the way, with Bash. That you can have some sort of a basic shell script that would run and execute. This could actually be quite complex. It could reach out to an S3 bucket and go and get a bunch more stuff. I work with some partners where you actually put the location of a license file in an S3 bucket in that user data to help kind of activate the instance or run a bootstrapping script that's maybe based on XML that's in an S3 file. There's lots of flexibility you can have with that user data section. It only runs the first time the instance launches, so you need to make sure you have it right. Test it out many times before you implement that in production. But a very powerful way to enable that your application to continue to run as it flexes out horizontally through auto scaling.
Oh man.
You all right?
Yeah, I forgot the public IP isn't launching. Hold on.
Okay.
Forgot a checkbox.
Cool. So as
obviously my first mistake.
Yeah, obviously.
In my career.
So for the people that are listening and watching at home or at work, Joe's going through and doing the auto scaling. We've created an auto scaling group. We've created an Elastic Load Balancer. But if I remember correctly from our architecture diagram, we still have this Route 53 entry that's actually going directly to an EC2 instance. So the question I would have to everybody is anything that we've just done going to have an effect or add value to the actual application that we're running, or do you think that we need to do some other things to help improve this architecture so that all the different components we've implemented can actually take effect and work? So send me your thoughts and suggestions here on what else would we need to change for that archicture. And Joe, if you could bring up that architecture slide again.
Sure. Right before I do this, though, just so we can point out, I updated I updated the auto-scaling group with the proper launch configuration.
Okay.
Right now, it's not going to launch a new instance because we're meeting the goal, which is one instance running.
Okay.
So right now, I'm going to terminate that instance, and then it'll launch the new version.
Okay, perfect.
Which, if I don't have a typo, will have Apache running.
Okay, perfect. And so we should expect to see an instance terminate here, and then we'll see a brand new instance come into play here as a result of. Okay.
First mistake ever. That was the second mistake ever.
Okay.
Second.
Okay. That's 2 in 1 hour, Joe. Okay.
But no, as you pointed, oops, that's not mine. Well, that's not good. So hold on, I've got to.
Okay. Do we need to switch?
Yeah, let's switch for a second.
Can we switch?
Hold on. It's like.
Sorry, everybody.
I just got to get my keys.
Tell you what, let's just talk through some of this stuff. I'll talk through some of this stuff. Can we unplug Joe? We'll let him get corrected here. Why don't you unplug Joe? What we're going to talk about next is I'm getting from the audience here is that they have some thoughts around redirecting the domain to the Elastic Load Balancer. So Route 53 is a super powerful service. It's kind of your top-level domain thing, and it can do lots of different things. As you can see, it can stream stuff down, or it can take requests and bring them directly down to an individual instance. But one of the things it can also do is it can actually interact with a service like CloudFront, or it can actually interact with your Elastic Load Balancer. So I think, Joe, it'd be a good thing. Let's walk through how would we actually take and configure Route 53, if you're all ready. Are we all good
absolutely.
On our side?
You know, one of the whenever I kind of get into a new account, one of the first things I do is actually dig into Route 53.
Right.
Because, you know, kind of starting at that top level, when you look at, let's say it's, you know, a website like www.domain.com, you know, my first question is, where is that pointing to? Because I don't want to be the guy that broke anything. And so, you know, I'll always focus on, oh, man, this goes to one instance or goes to an auto-scaling group. Wherever it is, that's where I'm very careful around modifications.
Right.
And that's also where you find out a lot of the times, where is the development environment, where is staging. So that's where I kind of always start my investigation.
Okay, cool.
So kind of looking at, so once again, let's get rid of that old instance. And then Route 53. So here we have the concept of hosted zones.
Right.
This is where in Route 53 we claim that we are authoritative for certain names. So the names that we say that we are authoritative for is this particular subdomain of Unicorn Rentals. This would, if we had www.domain.com or example.com, something like that, that's where you would see it listed here.
Right.
And here we have our record set.
Okay.
And this is really telling as far as what the current design is, since it's unusual to have the use of A records within AWS. So this is something that I'll probably dig into and view as suspect. You know, our recommendation is always, you know, probably use host names or aliases where appropriate, since that's part of our scaling decisions. I'm sorry, availability decisions. But yeah, this looks kind of suspect.
Yeah. So with this approach right here, we're actually, can you show me how do I know that it's going to a particular EC2 instance? Is it the value there?
Sure. Yeah. So remember, there are different types of DNS records, what we refer to as resource records within Route 53. An A record is tied to an IP address. A CNAME is tied to a name, and then AWS has alias records, so you can identify AWS resources. So here we see that this particular host name points to this particular public IP address.
Okay.
So
which is our EC2 instance, correct?
Well, it could be. I believe it is. It is. And then.
Okay.
And then, yeah, it's really interesting. So some people don't realize that when you search for, when you create search filters within EC2, you could throw anything in there. You know, maybe the security group that's assigned to the instance, the block device, backend, whatever it is, it'll just intelligently search through.
Okay. So we've established that Route 53 is still sending traffic to our individual EC2 instance, even though we've implemented a load balancer and some auto scaling. So how would we go and correct that so that we would have a better architecture where Route 53 is maybe going right to our load balancers?
So we have a couple of options. One would be kind of the more obvious solutions is we take the public DNS name and we can put that into what's referred to as a CNAME record. Remember I said there were names associated rather than IP addresses. So we could create like a CNAME and then put, and then have this be the value. One thing that kind of gets overlooked from time to time is the value that we have for the TTL, that's time to live, as far as DNS records. If you're going to rely upon DNS updates as far as an availability model, scaling decisions, anything, you want to ensure that you have a low enough TTL to hit your service limits. So here we have a 1 minute TTL, and that's pretty ideal as far as being able to make quick changes. A lot of times you'll see like larger values, and so you may not realize, oh wow, this information is cached, it's taking longer to fail than I thought. So this is just one of those little things we kind of point out from time to time.
Okay, cool.
Oh man. So I forgot, this is an Apex record. So for this particular instance, we're going to have to use an AWS alias, which hasn't updated yet.
So this is another interesting thing that we do find from time to time during game day is that, there it is. So sometimes it takes Route 53 or a few minutes to refresh for the rest of your resources. It's a global service, so there are a few delays that you see at times, but it's very minimal.
And so just for reference too, so that last error that I got, what does that mean? You can't have a CNAME in an Apex record, right? So right here, our host name is thisnumber.unicorn.rentals. Let's say you had a website like domain.com. The actual phrase, the top level domain, domain.com, second level domain, that would be your Apex record. So if you wanted to create domain.com, that would be a top level decision. You can't have a CNAME there, so that's where AWS makes the alias appropriate. This way you don't have to tie it to an IP address, and if there's a failure, there's a problem. So that's really helpful.
So that update took successfully?
Yes,
okay,
and
awesome.
So with our TTL now of 60 seconds, plus any other cached instances, after all of that works through, then we'll be able to view the update.
Awesome, cool. We got another interesting suggestion posted into the chat board by Storm of Dads, who's very active on the chat today. I'm not sure if this is one of somebody I know or not, but they actually talked about replicating the whole thing to another region and having Route 53 send traffic to both, which is actually it's an architecture you can totally do. You could actually take and run that EC2 instance in another region. So in our example, we're working in the Oregon region, but I could also have that EC2 instance running in the Virginia region. And I can actually configure Route 53 to balance traffic across instances in different geographies. And I can even give it a weighting as far as what percentage goes to those. I could also use a failover approach where it's sending all the traffic to Oregon, and it could say, like, if the health checks to Oregon fail, it'll actually start sending the traffic to the Virginia region. So there are ways that you could use Route 53 to have more of a geographically dispersed type load balancing approach, or even just a failover type approach if you're trying to have your primary applications here and you want to have some backup stuff over here. So there certainly are some ways you could implement that with Route 53 for an application running in one, or if you want to run the application across multiple locations at the same time. There are some issues that you would get into around replication of any data for the back end that we won't get into today, but at a high level, there certainly are some things you could do with Route 53. So another thing I'd like to talk about, Joe, is so now that we've got this architecture where we've got Route 53 flowing down to a load balancer, down to our autoscaling group, it's starting to smell and feel a lot more like some of the things I've talked about to people we've talked about, best practices and getting started boot camps that we've run. But how do we actually make this thing scale up or scale down? The actual application load. What are some of our options there?
Well, so this is where you kind of get into some of that creative thought. It's how can you think to scale it? Because there's a lot of decisions that we can make. when we have something like we're like AWS ELB, when we have EC2, it's tied in pretty closely with something like AWS CloudWatch.
Right.
And that's really recording a lot of metrics associated with the instances that are running, the load balancer that's running, and the traffic that's flowing across.
Right.
So what I always say is, really, at least take the time to kind of explore what's currently available in CloudWatch. There was a relatively recent blog post on enabling application logging from PHP monologue to AWS CloudWatch logs. What? Yes, I did write that, as a matter of fact. So that gives you some additional metrics, what you find in CloudWatch logs.
Right.
But take the time to just kind of go through and create your own logs, alarms based upon what information is currently in there. And so some of the examples are you could scale based upon CPU load of all the instances,
right.
Response times referred to as latency, whether or not it's responding to checks at all, if there's too much traffic going across something like bandwidth. It's kind of like your creativity is a little bit of the limit. We obviously give you some default metrics that you can use, but you can always add additional metrics to CloudWatch.
Yeah, I'd say the custom metrics are super powerful. I actually have some partners who their particular product needs to scale based on things like number of users, which you just aren't going to get because we give you what the hypervisor can see. So they publish custom metrics to CloudWatch, and they actually have scaling based on those. So I think that's an awesome example. One other thing I would call out here is that autoscaling isn't just built based on EC2. You can be basically on any metric that you really is relevant to your application. And ELB is actually another common place where you could actually have scaling events happen. So ELB's got metrics around things like latency with the actual communication between the ELB and the EC2 instance. If that's more of a driving factor for how you'd want to scale, that's certainly something you might want to take a look at. As we mentioned before, you can even use metrics out of like SQS to actually drive scaling events for your application. So really the sky's the limit. Think about the thing that's most important in your application as far as how you're building in those scaling metrics and the actions. So what are you showing us now, Joe?
So I'm running through, so let's say for instance that our decision was to scale based upon latency.
Okay.
So latency is the amount of time it takes for any particular response to be achieved. So we're saying that once our application starts lagging behind, starts getting a little bit slow in response times, that'll be the decision that we use in order to scale. So I'm just creating a CloudWatch alarm to be associated with that action.
Okay.
So you can, oh man. All right, never mind.
It's all right. What do we got?
So we're going to use a default one then.
Okay.
Here's where you would go to do that. I don't feel like typing out my email and everything, because I know everybody wants to contact me. So here, you would click on create alarm and then enter some information. And really, where you get this, a lot of this is through searching. So if you notice, there are 292 metrics here, all associated with individual services. And then there are some metrics that are automatically identified with our auto-scaling group. So, at the very basic here, we're going to look at what are the scaling policies. And as we said, minimum of one instance, and that's what we're working with. But we're going to add a policy, and we're going to call it scale up, if I could type. And we're going to, the average, one of the default options is CPU utilization. We also have amount of network traffic. And we're going to say that anytime we get above 50%, we're going to give the instance 20 seconds to get on board, and then we're going to scale up. Oops.
Cool. While you're doing that, I asked the audience some of the metrics that they use, and certainly queue depth is one that somebody came up with. That's the SQS type thing, and now that can be queue depth for SQS, or if you have some sort of custom queuing application, RabbitMQ, you can push those metrics to CloudWatch and scale off of that depth. That's totally possible. We have somebody who's actually asked us if they could hook Alexa up to an SNS topic and spin up some more auto-scaled instances every time somebody in the office says synergy. To my knowledge, you could totally do that because Alexa can take that and fire it off and call a simple Lambda function that would do something to SNS, call an auto-scaling group. I haven't dug deep into Alexa, but there are ways you could make that happen totally, and it probably would not be very difficult, although it may not be cost effective if you have that word mentioned in your office a lot. So.
And so, one thing that I actually forgot about until now, in the older interface, you used to have to, there was no option to kind of make some automated decisions. Mm-hmm. You would have to say, one CPU load gets above 50%, add one instance until things normalize.
Right.
And then, but with the new interface updates, you could actually offload a lot of that decision making, as we've seen in the example here. And a lot of times I think maybe some users didn't want to, or some staff didn't want to initially focus on those aspects of the configuration. So that could have driven usage of something like Elastic Beanstalk, where a lot of these details are kind of taken, worked through for you in an automated fashion. So it's interesting to see this applied through auto scaling right in the group.
Right. Now we did scaling up here, but I think scaling down is just as important in my opinion. You want to. You only want to pay for what you need when you need it, and you don't want to sit there and burn money and resources when you don't. So we can actually use the same or different metrics to scale down, if I remember correctly.
Absolutely.
Okay.
So I forgot, we didn't create an alarm.
Okay, no problem. But we have the ability to scale down if we want to, and it can be based on a percentage or the same metric or a different metric that would allow us to remove some of those resources. So I think that's an important thing that we actually, I notice in GameDay, is people are all focused about scaling up. Mm-hmm. And because they're focused on scaling up, they're often using a metric that does help, or they never get to the point where they actually get to the metric and they're just going and changing the minimum size. As they see load or they see failures, they're changing the minimum size. That might work for a 4 or 8 hour game day event, but when you talk about somebody sitting in an operations group, the last thing you want them doing is going in and changing the size of your fleet up and down as metrics are coming in. So investing in understanding what these metrics are and how you want to use them is super important for a longer term.
But just for reference, not to give away too much, but if you try to do that in a game day event, you're probably not going to end up towards the top of the board.
Right, because you're always going to be a little bit behind, and you're not going to know when things are failing until they start failing. So
or could you? I don't know.
Well, very cool. So we've obviously kind of scratched the surface on one scaling approach, and this particular approach kind of matches up with our architecture. We had some cool call-outs of scaling around ECS. I will tell you that ECS is totally possible for GameDay, and I think that's maybe something we should cover in a future episode, because that could actually be a fair amount of time that we invest in that. I could tell you the binary and the executable we give you to run would totally work on ECS. Lambda was another awesome option. So obviously, if your executable is running in a language that Lambda supports, you could figure out a way to turn that into a Lambda function and throw an API gateway in front of it potentially. So there's another option to be able to scale, because Lambda just scales for you. As many instances of a Lambda function you're calling, it will scale them out. So there's really no auto scaling you have to do. So those are both awesome options to talk about as well. And I think we'll find a way to cover some of those in the future, because I think that those are really important. Outside of, we've talked about scaling infrastructure, and we'll take a couple minutes to kind of close things up here. But outside of scaling EC2 instances, there's other things that scale on AWS as well, in different ways. Would you agree, Joe?
Absolutely, and that's one of the things that I always love about game day events, especially the larger one, is just the breadth of solutions that you find.
Right. I come from a database background, so I'm a little bit passionate about the RDS service, and RDS is very interesting because you can actually scale. You can only scale vertically, or you can kind of scale horizontally if you use read replicas, but you can actually, through a command line call, resize your RDS instance to make it bigger or smaller depending on events. And I've done talks about reacting to weekend traffic versus daytime traffic, or load in your work in your application, for example.
How many times have you tried to figure out the perfect implementation of MySQL multi-master clustering and just thought, I really need high availability here. Should I be using DRBD? What's my solution?
Yeah.
And now it's, one checkbox.
Yeah, it's pretty amazing. I mean, I've had people, in my old roles, have had people walk walk in September and say, I need you to tell me all the infrastructure you need for your databases for the next 12 months, and trying to predict that for the next year, let alone the next month, is pretty tough. So having other services like our database services that can scale up are super awesome. Lots of other services, DynamoDB scales automatically for you. We talked about Lambda scaling, ECS, kind of some scaling built in it for both the tasks and the EC2 instances you're using. Redshift can scale. There's a lot of cool ways that you can actually scale based on the demands that you're putting on your workloads in AWS. So it's not just limited to EC2. We focused on that because that's part of the architecture today, but there's lots of other things you can investigate. And if there's certain things you really, really want to see, please reach out to us and then throw it in the chat, and we'll find ways to talk about them in the future as well, and relate them into GameDay. We have lots of scenarios that we can try and tie these things into. Other than that, I think we wrap up here, Joe. We've got a lot of work coming up in front of us as we get ready for reInvent with GameDay, and I know you're taking a role in the GameDay and reInvent this year as well. Are you excited about it? Are you anxious for it?
I am. Okay. This is the biggest thing that we kind of work towards as far as reInvent. Our team, obviously,
right.
And it's really exciting. It's there's a lot of surprise. Competitors don't know what to expect at this particular event. It's not going to be what you saw last year, and it's not going to be what you saw the year before, or even the year before that.
Right.
So, kind of the question is, what could you see? I mean, I could tell you. Can I? I don't know.
I
definitely can't.
Too much, but I think you can expect some different services than maybe you've seen before, and some different approaches, but the same kind of wacky approach and the same really cool hands-on ability that you get with all the other GameDay events is certainly something I think you can definitely expect.
You could see me in a shirt and tie.
Yes.
Anything's possible.
So with that, I'd like to kind of wrap it up. And first of all, thank everybody for taking the time out of your day, whether it's your evening or your morning or your afternoon. We really appreciate you guys sticking around. Loved the interaction from everybody today. And so next week, we're going to be focusing on changes is going to be our theme. We're going to focus on, how do you deal with changes in your environment? How do you deal with code deployments or when you need to actually make a change to your architecture that you've already implemented, and how you would go about that. So we'll have lots of things, and it'll all be tied back into how we do GameDay. So we look forward to having you guys come out. And Joe, I really appreciate you kind of last minute and being able to step in for here. So I appreciate it, and hopefully we'll have you back on some other episodes as well.
Yeah. Thanks a lot for having me. Appreciate it.
Thanks, Joe.
Thanks,
everybody. We really appreciate it.
Bye.
Bye.